Imagine a world so colossal that 1,300 Earths could vanish inside it without a trace. This is Jupiter, the undisputed king of our solar system, the celestial titan we have always called a gas giant. But what if I told you that almost every textbook description of this planet is fundamentally wrong? What if this massive ball of gas is actually hiding an ocean of liquid metal deep beneath its swirling clouds? To understand the sheer scale of this mystery, we have to look at the numbers. Jupiter is not just big, it is heavier than every other planet in our solar system combined. If our Earth were the size of a single grape, Jupiter would be a massive basketball for centuries. We looked at its beautiful, marbled surface and thought we understood what it was. We saw those iconic clouds looking like the brushstrokes of a cosmic artist, and we assumed it was just a giant, airy balloon. The first close-up photograph of this enigma was captured by the Pioneer 11 spacecraft in 1974. Later, in 1979, the Voyager 1 mission gave us our first real glimpse of its motion. These images were breathtaking, but they were also a mask. They showed us the beauty of the exterior while keeping the true nature of the giant hidden in the shadows. We were left asking, what is this giant actually made of? And how did it become so impossibly large? Our understanding of how the solar system began starts with a massive, spinning disk of rock, metal, and gas. For millions of years, this cosmic debris collided, forming larger and larger fragments. Eventually, gravity took hold, pulling in more material, until one piece became so enormous it began capturing vast amounts of gas from the disk. This leading theory implies that deep within Jupiter, there must be a massive, incredibly dense core of solid rock and metal. However, there is another fascinating path Jupiter could have taken. Imagine a separate giant cloud of gas outside our early solar system that grew so heavy it collapsed under its own gravity. Much like how a star is born. In this scenario, the young planet was eventually pulled into orbit by our Sun. If this were true, Jupiter would have no core at all, existing instead as a giant, layered cake of gas. Most of us were taught the first theory of a solid core, but as it turns out, even that traditional wisdom is not quite right. The breakthrough we needed to understand Jupiter arrived in the mid-1990s through a cosmic coincidence that seems almost too perfect to be true. In July 1995, the planet was struck by a comet, an event estimated to happen only once every 6,000 years. We were incredibly fortunate to have the technology ready to witness it. This comet, named Shoemaker-Levy 9, was a massive fragment of ice and rock hurtling through space at 216,000 kilometers per hour. Jupiter's intense gravity had already torn the comet into dozens of pieces, with the largest chunk measuring about 2 kilometers across. NASA's Hubble Space Telescope was prepared to watch, but there was a significant problem. The impact was set to happen on the far side of Jupiter, hidden from Earth's view. However, in another stroke of incredible timing, the Galileo spacecraft was just arriving at the planet. Over the course of 6 days, Galileo witnessed 21 separate collisions. The largest impact released energy equivalent to 300 million atomic bombs, creating the most powerful explosion ever recorded by a camera. As Jupiter rotated, Hubble captured the aftermath, massive dark scars in the clouds and plumes of debris rising thousands of kilometers high that remained visible for months. The Galileo mission provided more than just a spectacular light show. It gave us our first physical samples from deep inside the giant. As the spacecraft flew through the massive plumes of debris kicked up by the comet impacts, it tasted the secrets hidden beneath those ancient clouds for the very first time. The most shocking discovery was the presence of water, and a lot of it. This finding was so unexpected that it forced scientists to completely rethink their theories, leading to a new mission designed specifically to uncover the planet's true nature. That mission was Juno, launched in 2011 and arriving in 2016. Juno began peeling back the layers of the mystery. What we have learned in just the last decade proves that almost everything taught in schools for generations was incomplete. Your science teachers didn't know then what we know now. Jupiter is not simply made of gas. Those iconic, swirling storms and colorful rings are merely a thin, deceptive shell. Beneath that beautiful exterior lies a world far more alien than we ever imagined. To truly understand what is happening inside Jupiter, we must begin our journey at the very top of its atmosphere, where the environment is more alien than anything we can experience on Earth. At these heights, the temperatures are bone-chilling, dropping well below negative 150 degrees Celsius. It is a world of frozen crystals and violent chemistry. Here, water ice crystals mingle with ammonia, which serves as a remarkable natural antifreeze. This chemical interaction allows liquid water to exist even in the freezing upper reaches of the clouds. As these water droplets and ice crystals collide, they generate massive amounts of static electricity, turning the clouds into giant batteries that discharge as colossal lightning bolts, flickering across the entire face of the planet. This volatile mixture of ammonia and water eventually freezes into strange, slushy hailstones, known as mushballs. These heavy frozen masses fall through the atmosphere into the warmer layers below, where they melt into rain, evaporate into gas, and then rise again to restart the cycle. This continuous movement is fueled by powerful jets of hot gas that rise from deep within the planet, feeding the monstrous storms we see raging on the surface. The most famous of these storms is the Great Red Spot. It is a crimson vortex of such immense proportions that it defies human comprehension. This storm is not just thousands of kilometers wide. It also reaches deep into the atmosphere, extending hundreds of kilometers down into the ammonia rain. The Great Red Spot sits higher than any other cloud formation on the planet, pushing its way above the surrounding layers. This height allows it to absorb intense ultraviolet light from the sun, which triggers a chemical reaction that gives the storm its iconic and haunting deep red color. To grasp its scale, imagine a cloud that is 10 times higher than Mount Everest and 10 times deeper than the deepest parts of our own oceans. Yet, as massive as this seems, the entire visible layer of ammonia and water clouds is only a thin skin, roughly 50 kilometers deep. As we descend beneath this thin veil of clouds, the environment changes drastically. The temperature begins to climb, but not because of the sun. This heat is generated by the crushing weight of the planet itself. Gravity pulls everything toward the center, compressing the gas molecules so tightly that their energy becomes concentrated, creating intense thermal energy. The further you sink into this gravity well, the more the heat and pressure intensify. It is like traveling through a fog that becomes thicker and thicker, until the air itself begins to feel like a liquid. In this extreme environment, the primary element is hydrogen, the lightest and most abundant substance in the universe. Under the weight of Jupiter's gravity, hydrogen is the only thing that can remain at these levels, as all heavier elements have long since been pulled deeper toward the core, at a depth of approximately 1,000 kilometers below the cloud tops. The pressure becomes so great that the hydrogen gas completes a physical transformation, turning into a liquid. This is the closest thing Jupiter has to a surface, a vast, global ocean of liquid hydrogen. The largest ocean in our entire solar system is a world where the boundaries between gas and liquid disappear, and the pressure is high enough to challenge everything we know about the states of matter. As we sink deeper into the celestial abyss, leaving the churning clouds of ammonia and water far above us, we enter a realm where the laws of nature are stretched to their absolute breaking point. At a depth of approximately 1,000 kilometers, the transition is complete. We are no longer drifting through a gas, but submerged in the largest ocean in the entire solar system. This is a world of liquid hydrogen, a substance that exists on Earth only in high-tech laboratories at temperatures near absolute zero. But Jupiter is a planet of contradictions. Here, the hydrogen is not freezing. It is a scorching, pressurized liquid. On our home planet, we can only turn hydrogen into a liquid by cooling it to a staggering negative 250 degrees Celsius. Jupiter, however, uses the sheer brute force of gravity to achieve this feat. The pressure is so immense that it raises the boiling point of the hydrogen, forcing it to remain in a liquid state even as temperatures soar well above 1,000 degrees Celsius. This alien ocean is not a shallow sea. It is a staggering 20,000 kilometers deep, reaching down into the darkness 2,000 times further than the deepest trenches of Earth's oceans. As we descend through this massive reservoir of liquid energy, the environment becomes even more extreme. The crushing weight of the layers above becomes almost impossible to comprehend. When we reach the bottom of this hydrogen ocean, we encounter a boundary where reality shifts, once again. At a depth of roughly 20,000 kilometers, under pressure, millions of times greater than what we feel at sea level on Earth. The very atoms of hydrogen begin to collapse. At temperatures reaching 10,000 degrees Celsius, the hydrogen undergoes a radical metamorphosis into a state known as metallic hydrogen. This is the true secret of the giant. In this state, the hydrogen does not become a solid block like iron or steel. Instead, it becomes a thick, shimmering liquid metal, perhaps resembling the flowing mercury found inside a traditional thermometer. This transition is the key to Jupiter's immense power. In this metallic state, the pressure is so violent that it literally squeezes the electrons away from their parent hydrogen atoms. These free-roaming electrons are allowed to flow through the liquid without resistance, creating a massive swirling current of electricity. This layer of metallic hydrogen is the engine room of the planet, making up the vast majority of Jupiter's interior. It is a massive mantle of liquid metal, nearly 40,000 kilometers deep. Imagine a sea of electricity conducting fluid so large it could swallow the Earth several times over. It is within this churning, metallic depths that the planet's powerful magnetic personality is born. We are now far beyond the reach of any sunlight, surrounded by a glowing, electrified sea of metal that hums with the energy of a world that is more star-like than planetary. We have traveled through the storms and the liquid oceans, but we have yet to reach the final destination. Deep beneath this 40,000-kilometer layer of liquid metal lies the most mysterious part of all, the core. For decades, scientists believed this was a solid, rocky ball, but the truth revealed by modern science is far more complex and far more haunting. We are standing on the edge of the final frontier of the gas giant, where the distinction between solid, liquid, and gas finally vanishes into a soup of primordial matter. For many years, we believed we knew exactly what lay at the very center of the king of planets. Science textbooks often described a clear and distinct structure, a compact, dense, and solid core roughly the size of Earth, composed primarily of iron and heavy rock. It was a neat and tidy explanation that fit our traditional understanding of how planets are built. We imagined a hard, rocky heart buried beneath those tens of thousands of kilometers of liquid metal, providing the gravitational anchor for everything else. However, modern research and the data sent back from our latest robotic explorers have shattered that simple image. As it turns out, the truth is far more chaotic and blurred. Instead of a solid, defined ball, Jupiter appears to have what scientists now call a diffuse or fuzzy core. There is no rigid line where the metallic hydrogen ends and the solid core begins. Instead, these layers seem to bleed into one another in a vast, messy transition zone. This diffuse core is not just a small point in the center. It is massive, spanning roughly half of the entire radius of the planet. Imagine a dense, swirling soup of liquid hydrogen, heavy rock, and molten metal, all mixed together without a clear boundary, where one state of matter ends and another starts. This discovery has left astronomers questioning whether this strange internal structure is a common feature for all giants or something unique to Jupiter alone. Because we have not studied Saturn with the same level of granular detail, we cannot yet be certain if it shares this same fuzzy heart. This uncertainty has led to a fascinating and violent theory. Perhaps something happened to Jupiter in its infancy that changed its destiny forever. The leading theory suggests a moment of incredible primordial violence. Scientists believe that during the early, chaotic days of our solar system, a massive rocky planet, perhaps 10 times the size of Earth, may have been wandering through the darkness until it collided head-on with the young Jupiter. The energy released from such a titanic impact would have been enough to shatter a solid core, scattering and diluting its materials into the surrounding layers of hydrogen. This ancient cataclysm might even help explain how Jupiter managed to grow to such an impossible size, as it absorbed the remains of its fallen rival. To test this idea, astronomers turned to advanced computer simulations, running countless scenarios where planets of various sizes and compositions smashed into a young version of the gas giant. At first, the results were promising, as the simulations did indeed produce a diffuse core similar to what we observe today. But then, the mystery deepened. In every single simulation, the scattered material eventually settled and solidified relatively quickly, meaning Jupiter should have a clearly defined solid ball at its center by now. Yet, it does not. We are left with a profound scientific paradox. We know Jupiter has this vast, strange, and fuzzy heart, but we still do not fully understand how it got there, or how it has remained in that state for billions of years. It is a reminder that even with our most advanced technology, the largest planet in our solar system remains a giant mystery in the sky, a world that defies our expectations and challenges our understanding of the universe.